For this problem together. First, you were asking, or your mom was asking about time. So just as real quick, the structure of the exam is set up this way. You have multiple choice in section 1. There's 40 questions, and this is 2 hours, and it's divided into 2 sections. That part A is 28 questions. You have 80 minutes for that section, and you're not going to have your calculator. Part B is just 12 questions. You have 40 minutes, and you're allowed to use your calculator. It's required. They're going to want you to use it. Then you have the free response, which is an hour. It's 4 questions. Again, you have some graphing calculator required, and you have some that the calculator is not permitted. The question that we're working on, the ice cream cone question, is one of these kinds of questions. It's a modeling in a non-periodic context. All right, so it would be an example of this question 2. So when I'm approaching this question, before you can see all of these are divided into parts. You have some information about the problem, and then you have parts. So what I would do is I would kind of look at the whole picture first. Notice this is a calculator problem, so you'll be actually to turn on Desmos when you work on this problem right in the test. So the test is a digital test, and you'll be able to activate Desmos right within your test. I have it up here as well. And I'm going to kind of talk about the ways in which the calculator can make this go very quickly. And one more thing, if we see how long would we have on this question, well, it all depends. Technically 15 minutes and 15 minutes, but if you did one faster than the other, then you would have a little bit of extra time. All right, so again, let's just read it. We have, make sure we know what these variables mean. It says we have, the table gives the number of ice cream cones sold by a food vendor on initial day. So this is day 0. We sell 14 cones. 35 days later, we've sold 57 cones on that day. 10 days after that, so 45, we've sold 46 cones. So we have this table. And they're telling us that it is a quadratic function where I of t is the number of ice cream sold on that day. So we could switch these I of t and t to x when we're in Desmos. Part A is wanting us to find the values, right? They want us to find the model. All right. Use the 3. So what? 3 equations, right? So part 1, we have to absolutely write without using. We have to do this without a calculator. But there's nothing that says how we solve question 2, whether we use a calculator or we don't. And I'm going to show you how I can see right here, you solve this using the systems of equations. And just real quick. Oh, let's just keep reading and then I'll come back. So you knew how to solve the systems of equations. Part 1 wasn't asking this for B to A and B. It just wanted you to put the values in here and make 3 equations, right? So it wanted you to say, put in 0 and you have 1 equation. But I think you simplified it, so I think you would get the points there. I gave them to you on the question. All right, so you set that part up. But I would have read this all before I started. I kind of am skipping over that. It says use the data, the given data to find the average rate of change between 35 and 45. Express this answer as a decimal approximation. Show your computations. So that obviously is something we have to do. We have to write it out. And we can't necessarily just use the calculator. Use the average rate of change you estimated to find day 40. Show your work of how you got to that. Compare that estimate to the model, and then explain, so why would these 2 be different? And you really had a lot of these ideas. And then it says explain how the range values will limit the context of the problem. All right, and this is a calculator question. So if I was solving this, I would want to see it. So if you go to the little plus sign in Desmos, you can click on a table. I already put the data in real quick, but you enter 0, 14, 35, 57, and 45, 46. And I went up here to the little wrench, and I wanted this to go out to 70 days and go up over 60 ice creams so I could see all these points. And it's very clear that we have some sort of parabola going on. And to have Desmos do this, we worked on this on some projects through the year, but I used y sub 1. And I use the little squiggly, and then this is going to be a x sub 1 squared plus bx sub 1 plus c. Now, why am I using the sub 1s? Because that's where the variables are stored. So I'm just telling it where to go. And you can see that we get the same values that you did using the systems of equations, right? And like I said on the question, you would need to, where'd it go? You would need to set up the three equations, but to solve the three equations, you can choose whether you do this. This is very long to solve it by hand. It's very fast, as you can see, to solve it with the calculator. So that makes it be very quick. All right, now for part B, we need to really think about what they're asking us to do. And the picture again helps us a lot because they're asking us to find, I actually want this to go up just a little bit higher, maybe 70 there. That's a little bit better. So the rate of change is going to be this secant line, right? The line that passes through these 2 points. And I solved this, which I think is the same way you did, right? I just simply said, okay, the average rate of change is the change in y values divided by the change in x values, and you got negative 1.1. That's not very complicated mathematically. And then I wrote this out algebraically of how you do this with a secant line, but let's just, I'm going to do it on Desmos again here for you because this makes it very fast. So I want to know, I want to know what's the secant line between these 2 points. And do you remember you have 2 points and you want to do a straight line. So that's y minus y1 equals m times the quantity x minus x1. If we remember point slope form, then we can, I'm going to show you how to put the values in here in just a second. If you didn't remember point slope form, right, and you're like, what am I going to do? I don't remember how to get this. If you just imagine a line, like you could just draw it, right? It's going to be something underneath of here. When it's 40, my goodness, does it look like that line is right, I don't know, between 50 and 51, right? So you could get a really good guess by just saying, I looked at the graph, right? And it looks like the line passes through that point. But let's finish it. So y is, when we're using slope-intercept form, y is in our equation. y1 is, we're going to use this, we're going to use 46, right? Because this is the y value. The slope we found was negative 1.1. And the x1 value that we need, it has to correspond with the point I used in y, so it has to be 45. And we can see that is that line. And if you wanted to, you could put in the value of 40 here, right? Because then you're going to find exactly what that value is, right? 51.5. Or you could do it like this, x equals 40, and you could find exactly, this is going to be very fast because we're going to see this difference in the third part. So when I use that line and I use this secant line, the purple one, then the number of ice creams is 51.5. And that really brings us to part 2 is says, or compare the estimate, part 3, compare the estimate and what our model says. Well, our model says 52.79, right? And why are they different? And you hit on this, the parabola is going to curve around a little bit, and this secant line is going to pass through. And since, if you want to use, right, the graph is concave down and it's decreasing, so that means that this is going to be an overestimate and this is going to be the underestimate. All right. And the last part was explain how the range values of the function, computer's doing that on its own. Explain how the range value of the function should be limited by the context of this. Yeah. And you have half of it. I can't sell unlimited ice cream cones, but my problem, right? This is about 59, right? This parabola has a maximum that is about 59. So I can sell at most, right? There's a time here somewhere under 30 days where I sold a maximum number of ice creams of 59. So my range should be between 0 ice creams, right? Day 63, I sold 0 ice creams according to this model. And I went all the way up to selling 59 ice creams. So that's going to be the last part. All right, so I think that this can be done in less than 15 minutes. I think that trying to do it algebraically makes it slower than it has to be, although if you're super with your algebra, it could go faster. And using, making sure you're practicing with Desmos, or all of this could have been done on a TI-84. It's just a whole lot easier for me to show you on my screen. So let me know if you want to talk about this some more. I'm very happy to help.